In this video of the 4-week startup, alright, well somehow I need to make this wearable product handle rainy conditions. I have 4 weeks to try and build and launch a product from scratch. And this means thinking of an idea, building a product from scratch, marketing, and even making an important decision which could affect our launch date. Alright, what's the total manufacturing cost for 10 pieces? And as I speak, it's now day 23. We're gonna launch this product in 7 days. But let me get straight to the point. This is the final product so far. This is LightVest. LightVest is a wearable bike safety vest designed to increase a cyclist's visibility on the road, which also includes turn signals. It features front LEDs which can be customized, as well as backlights which can indicate left or right. But that's not all. LightVest is smart enough to automatically brake when you slow down, or even activate the hazard lights in emergencies, as well as being fully lightweight and portable. With this wireless remote, weatherproof materials, and a power button, 4 weeks later, this is the product. In this video, we're focusing on the process of building a product. This is going to be quite a journey, from thinking of an idea to hopefully getting it to launch. I'm Eben, and you're watching a 4-week startup. To build a startup, I'll need to identify and build a product that satisfies a need, ideally providing a solution to a problem that offers value to our potential customers. And we're going through the whole thing. This means even making a website and an Instagram ad campaign. I have $500 to get this right. Okay, so why this video? Why are we trying to build a product and launch a startup in 4 weeks? Well, here's some reasons. Well, firstly, we've been building projects, but it'll be interesting to see how we can turn a project into an actual product that a customer can use, providing a solution to a problem. Secondly, I think this might be an interesting experience, whether this works or it doesn't, and it might be something we might learn from. And hopefully, this might be helpful for those who are still on the fence and looking to start something. And the last point, why not? But to keep true to this journey, we need to lay some ground rules. These are the rules. Rule number 1. I have to attempt to launch a product in 4 weeks. Rule number 2. This video is focused on the product side of launching a startup without any outside investment. So I'm bootstrapping this launch with my own $500 cash. And the last rule. Since this isn't going to be a full-time thing, we're going to have to pull this off in the late evenings and weekends. Well, somehow. So when we think of a startup, the first thing that might come to mind is hearing news on a company gaining a large valuation, or a revolutionary startup being bought out by a larger company. But what exactly is a startup? A startup is a young company being founded by one or more entrepreneurs to develop a unique product or service and bring it to market. The typical startup tends to be a shoestring operation. But right now, that's as much as I know about startups. I'm going to take a deeper look and see how one works and how we can apply it to our own. Cue montage. Right, let's start this. Thinking of an idea to solve an issue is quite interesting, as there isn't a wrong way of doing this. One method is combining two unrelated ideas to generate a new idea. For example, a pie plus a frame plus a display can make an interactive pie picture frame. Another way is brainstorming real-world problems. Writing any idea that comes to mind with a bit of word association, getting something like this. For example, portable transport and electric skateboard. Using keyword analytics, we can gain more data on our problem we're trying to solve, looking at the search volume and the long tail keywords. This can help us get a better understanding of the competitors and any existing customer issues. Finally, shortlisting any ideas that make the cut. This is the criteria I'm focusing on. But finding a product that fit the budget wasn't exactly an easy task. If I need to find a product, I need a product where the barrier of entry is relatively low and there's some level of niche that solves an issue. I'm going to take a break to think this through. Okay, I think I got a project idea. Let me explain. Ready? LEDs. Yes, LEDs. The type you find in your electronics, your bulbs, and your microphones. How I got this idea? Well, thanks to these LEDs. Thinking more on the products we shortlisted, most of them were too expensive. I needed to think of an item or an idea that fit the budget. And it was like the idea was on the wall staring right back at me. Yes, LEDs. And thanks to new manufacturing methods, the price of one LED component is pretty low. But not just the standard roundhead LEDs, but the 50/50 LEDs too. Like the ones on the wall that change color with a remote. And these are relatively cheaper in larger quantities. And with its own embedded driver, this means that we can control it to any color, well, according to the datasheet. Meaning, this could be a good start. Hey, it was either this idea or an automatic protein shaker. Searching Google, there were some good LED real-world use cases, but one thing that caught my attention was wearable LED lights, which was an interesting idea. But an even more specific use case of wearable LEDs can apply to the industry of bikes. Have you ever ridden a bike? What do you tend to do when you signal left or right? You tend to do this. I mean, cars have turn signals / blinkers for indicators, but bikes don't. What about if we take the idea of turn signal indicators for cars and apply it to bikes, therefore increasing cyclist communication? Now, the supposed market share of the LED industry is set to have quite a significant rise by 2025, but we can't capture the whole market without diluting a product to something generic. So we have to focus on making a product that solves a single issue. Now, this wearable LED will have two functions: being clearly visible at night, increasing the cyclist's confidence, as well as being clearly visible to other motorists on the road, perfectly mimicking car-like turn signals, whether we want to turn left or right, or even apply the brakes. And we can even add a microprocessor so we can connect our devices like our phones and track progress like how far we've ridden. Now, this product is definitely going to be on the novel side, even borderline polarizing, but this may be a good thing. A bit like the Harley bikes, they focus on a specific demographic and a niche, and the advantages here is that we can carve ourselves a specific niche in the wearable LED market, and possibly even attract some innovators in the early process of the life cycle. Looking at the competitors, they look pretty decent, and I believe there is some room for innovation. If anything, we can focus on improving a couple features, for example, the remote. And the remote here is a good idea, but it still seems you still need to manually control it when you're riding a bike, which isn't ideal. So if there's one thing we can do to improve this, we can make some type of hands-free remote that will be attached to the bike frame. So when we turn the bike, the turn signals automatically register without any direct user input. So a summary of the problem. Cyclists at night have reduced visibility, making it difficult for other motorists to see cyclists from a distance, especially when a cyclist is turning left or right. So this is our solution, and hopefully it provides value. A wearable LED bike vest that's focused on helping cyclists' visibility during the night, using LED light indicators to signal their intent of turning, and with the goal of reducing the possibility of cycling accidents. Okay, it's now time for us to start building. Let's build ourselves an MVP. So according to Y Combinator's Paul Graham, one of the biggest problems startups run into is creating a product that nobody uses. This could mean spending thousands of hours of research on a product only to realize there's no need for the product, or the market has moved too fast as there was no release of an earlier version of the product. So we'll need to figure a way to release early, fail fast, and have a feedback loop from our customers. And to keep us adapted to changes, we can make an accelerated version of the product we have in mind. And we can call this a minimum viable product, or the MVP. So what exactly is an MVP? So an MVP is a rough version of the idea that takes a minimum amount of effort but is still good enough that a user could get a good grasp of the core features of the product, who can then provide feedback for future product development. And it's now time for us to spend some of our investment. And here are the parts for the MVP. Code schematics and instructions can be found in the description below. For subscribers, get 2 for the special offer of 2. Call +44 741 291 LED. Terms and conditions apply. This will all make sense by the end of this video. So how did we end up with this final version? Well, I went through a few prototypes. The first prototype was there to prove whether this was actually possible. The second prototype goal was to test weatherproofing in the rain. Here's a side-by-side comparison. Lastly, coming to the final version. But let's break down how it works. Essentially, we have a remote and a vest, which communicate wirelessly. When a button is pressed, the LED lights up. Having a closer look inside, this version is prototyped with an Arduino. But let's have a closer look at what's going on. Here's a view of just the electronics. We're using a Bluetooth module for communication and a switch for the remote. When we press a button, an action is sent to the vest to light up the LED, in this case the right indicator. And the same similar to the left. So that's how it works. Let's focus on how the LED vest is built. The main components for the vest is the LED strip and the Arduino. Ideally, we have an LED strip controlled by an Arduino powered by an external battery source. Having a closer look, the strip consists of 50/50 RGB lights with an LED driver integrated, with wires to connect to, which means they're controllable so that we can pick any RGB color. Here's a look at the breadboard schematics of the vest, and this is what we're going to build. Once built, we can load the test program to verify everything's working. This specific code lights up all the LEDs within the strip, changing colors. And to be honest, this will look quite good in a room. We can then make this portable by having it powered by an external battery source. In this example, I'm using a standard 2000 mAh power brick. Given that each LED draws around 20 mA at full brightness, this is enough for the prototype. Now, the design I'm going for is something more casual that goes with sportswear and can even look good while running. I finally got the parcel, and to be honest, I was pretty impressed with the quality given the price. We have 2 zippers and the material has already got some level of water repellent to it. So now we got to somehow put the LED strips on the vest, and we can pretty much go for any shape. I'm going for more of a diamond look. We can then cut the LED vest specifically at the connection pads, and we can reattach these LED strips in any shape. You can either solder these back in, but I prefer to use L-shaped connectors as they're just easier and they look a bit cleaner. Precisely lining them up to get a good connection is important, as each LED relies on the data line. Any loose connections within your LED strip would end up with weird color distortions. And we can just connect them all in place. I also 3D printed some L connector cases, which would add another layer of protection, which can be simply snapped on. And we can do this for all four. We can just reconnect the breadboard schematics to control the LED strips and connect an external battery power to power the LED strips. And there we have it, the basis of an MVP. But we still need to program the microprocessor, as we still need the turn signal features. And after uploading the code for the prototype to the Arduino, this is what we'll expect. Also, the good thing about this vest is that it has many compartments. And now that we've programmed the basic turn signal indicators, it's now time to test out the features. So the idea here is when we ride the bike and turn left, the vest will indicate left. And if we turn right, the vest would signal right. And an additional feature, if we see any emergencies/incoming hazards, the vest will start flashing the hazard light. Okay, that's the LED vest done. Let's get back to the remote. So to recap, when we press a button on the remote, the vest lights up by sending data to the vest, triggering a function over Bluetooth. This is the schematics of the remote. A 3D printed case was also created to house the electronics. This way we can switch the remote on and control the vest wirelessly. But there's one problem. We're now creating another issue. The current version now requires you to wave the remote around while you're riding the bike, which isn't the best. And luckily, taking a lesson from the previous video, well, let's sort this out. This little component here has an inbuilt accelerometer and a gyroscope. It's known as the MPU 6050. You can see this in different projects and products ranging from drones to self-balancing robots. Now the theory here is since we have an accelerometer, we can track the rider's sudden change in velocity. Combining this with the onboard gyroscope, we can use this data to measure the rider's change in orientation. And using a microprocessor like the Arduino as the brains of the remote, we can receive data from the MPU down to the millisecond, meaning it's going to be pretty accurate. And this means as we turn the bike, the remote will also know whether we're turning left or right to the precise degree, making it pretty smart, so we can control the vest. And if you're wondering how the logic of the code will work, it's going to be something like this. Are we going straight? Yes. Are we going straight? Yes. Are we going straight? Nah. What are we doing? We're turning left. Ah. And in another function, this is how it works. Are we going straight? Yes. Are we going straight? Nah. We're turning left? We've crashed. Huh. In order to scale the operations of this startup, I'll need to build a team of experts and someone who has, well, a better eye for design. And this is where I call an old-time friend. Yeah, so the idea is making a safety vest for bikes using lights as turn signal indicators. Yeah, it's a video idea, but I think it blew out of proportion a bit. But it'll be great if you can join the team as a lead designer. Alright, cool. I'll send you more details on it in a bit. This is Francis. We've known each other since primary school. He pretty much works on anything creative, ranging from art sketches, fashion, design, and even clothing. His creativity and aesthetics would help make this product more appealing, getting rid of that bright yellow construction safety jacket look. And this is Francis's approach to weatherproofing the vest.
And then source materials are weatherproof, and then cut the pattern from that, and then reconstruct everything so that the whole vest will be weatherproof.
So to prove this point, Here's normal cotton fabric on the left. Notice how it absorbs the liquid. And on the right, we have the weatherproof material, which simply resists the water from passing through. So it's time to change up the design and upgrade the materials. Building the product can be broken down into 4 segments: the design, the electronics, 3D printing, and putting it all together. So Francis is taking the design to make it, well, more fashionable, as well as sewing in the water resistant material. Testing out the vest, the original fabric was removed and the weatherproof material was sewn in to the back of the vest. Going from this to this. And by using the water resistant material, this prevents the vest from soaking in water from weather conditions. And the good thing here is that the strips can be removed if you want to wash the vest. And using a Velcro buckle, this can quickly be installed or removed, while giving you a good flexibility when it's being worn. Now, creating a PCB is very helpful to reduce the size of the remote and keep everything in place, as the breadboard version is more for prototyping. And this is the assembly of the PCB board for the vest. This was then sent to a PCB manufacturer, where we can expect the delivery of the boards within a week. And now onto 3D printing. This is an earlier version of the remote. Now, reducing size matters, especially for the remote. The goal here is to reduce the footprint of the remote on the bike frame. And that's why we went from a larger breadboard version of this to something more compact, like a PCB version. Okay, there was a few more prototypes in between. Main reason is we wanted it to be pretty tight and use a screw system to keep the electronics in place. This is the design we settled for, which is ideal as it can be mounted onto the bike frame. The same was done for the 3D printed enclosure for the vest. An LED push button was added to the vest, as well as cleaning up the look. And our electronics can be safely secured in an enclosure. Alright, and now we test this. The pilot test. Here are the front lights and the back lights. And we can turn off the vest using this LED push button. So you may be thinking things are on the up. We found an idea, we built an MVP around it, and we got a team of 2. Everything's just going just fine. Wrong. We still got quite a bit to cover, main thing being manufacturing and scalability. Alright, what's the total manufacturing cost for 10 pieces? This is me speaking to one of 3 manufacturers. And here's an estimated cost of the vest. The direct material cost per vest is around $50. Although we can reduce the cost by using dedicated electronics, the elephant still in the room is how do we make larger quantities of this project? In other words, scaling. These suits are really labor intensive to build and our $500 budget is going down. We still got to figure this out and there's a lot going on, but that's for later. We still got a brand to make, so let's get to marketing. Sell me this pen. How would you sell me this pen? Now seriously, comment below your best pitch. I'll reply to every comment below. We've now got a working prototype, and time's ticking. We'll need to build a brand around the product. And that's why we'll need a marketing campaign. Marketing is going to be very important, as we could have the best product since sliced bread, but if no one knows about it, does it really exist? I mean, yeah, it does exist, but... And to do this, I'm going to have to create a brand name, a website, and an ad campaign. I'm going to use Instagram for the ad campaign. Now, thinking of a name can be quite challenging and fun at the same time, as we're trying to find a name that represents the LED vest. So I tried brainstorming and I created a list. But it turns out that each and every product was taken. Now, I'm pretty bad at naming stuff, and that's when you guys came in and saved the day. I posted the idea of a startup video and what I'm up to on Instagram, and I asked for some startup names, and that's when you guys really came through. And hey, shout out to Brazil. I mean, Helios.io is a great name and it fits well, but it was taken. And yes, even the .io extension. Yeah, the way my bank account is set up, yeah, that's out of my budget. I shortlisted all these ideas and put this into a community poll, and LightVest came out as the winner. And thankfully this was available. And shout out to I am Jean-Pierre for the original name of LightVest, and everyone else who submitted. I appreciate that. And to be honest, LightVest is a good name, and we're quite lucky on this as it's great for SEO. Although it's a competitive term, anyone who searches for the keyword LightVest is more likely to stumble on our site, as it's pretty much an exact keyword match. And to be honest, using the .io extension was just so it sounded more like a startup. Okay, we've now got the name LightVest.io, but we still need some type of way to promote our product. And to do this, we're going to make a campaign for Instagram. Let me get straight to the point and show you the video. And this is the ad campaign on Instagram that's going to promote the product and its functionality. After setting up a campaign, it's now time to promote this product on our Instagram page to our target audience. And the marketing ad is now officially live. Link in the description below to our Smart Builds Instagram page to see the below results. But right now, I got some new updates. Remember the manufacturers who are building the vest for production? Yeah, they got back to us. I can't really show the conversation, but here's a reenactment. So how much is the cost to at least manufacture 5 LightVests? 500. Yeah, to be honest, $500 was pretty tight. Take into account the distribution line, the packaging, and the certifications. Yeah, we don't have much of investment left. The progress of LightVest is in a bit of a stalemate. I mean, the capital's gone, the manufacturing costs are out of the budget, and we're still waiting on a batch of PCPs I've ordered. Scaling this product is definitely going to be a big issue, but let's take some time to think over it. We got to change the strategy, and one way we can do this is by pivoting. One of the biggest issues we're facing is scaling LightVest. We'll need to ideally pivot our strategy if we're going to somehow launch the LED suit. And how can we pivot? Well, I'm calling this the IKEA approach. IKEA's business model works on providing the customers the whole unassembled product in its package, which is assembled in a DIY fashion, which means that they can have lower prices as they don't spend as much on the assembly process. And this approach works in the long run, as they can pack more volumes of their items per shipping, as they use less space. So bear with me, this is the idea of the pivot. Rather than making a complete product, we're going to pivot the business strategy by taking the IKEA approach. This means that our cycling customers get the parts as a kit and builds their own version, a bit like assembling a table. And by making the diagrams, schematics, and code free and openly available, this product would be made open source and hopefully encouraging a community to improve the functionality and give the opportunity for contributors to improve the design. For example, adding a GPS tracker or improving the design for all weather conditions. And I guess now it's an open source startup. This solution can solve two issues at the same time: our scalability issue and our logistics issue, as well as encouraging safety and transparency through open source contribution. Now, as mentioned, this product is definitely on the novel side, and would only appeal to a certain niche. But since we're in the early stages of LightVest, this can be refined further for different use cases. For example, running. Okay, we've now got our PCB boards delivered and we've only got 1 day left. I hope they work the first time. This is the PCB of the smart remote with the components from earlier on. It's now time to solder. Right, so now we've soldered all the components onto the PCB. I'm just hoping it works first time. This is the moment of truth. One thing I like to do is actually test the voltage of the board, so I make sure that everything is actually well connected. So the moment of truth to see if it actually does work. Just look at it. Right, I'm just glad it works first time because this is going to put us slightly ahead of the project. We even got the red lights showing and the programmed lights that show on different sections. So I'm pretty happy with this. I think that's enough for today. We'll continue. I'll see you next evening. We've gone through a lot in the past 4 weeks, from an idea to building an MVP, from prototyping to solving issues, and even building a team to improving the product. And from marketing LightVest to even changing our business strategy, making it open source. Well, we're now at launch day. And just like a Tarantino film, we're back where we started. This is LightVest. I think we've got to pack up, it's kind of getting late here, so I'll catch you inside. And the date is the 28th of February, and we've officially launched. Now, just to be clear, I don't really plan to do much further development with this product. This was more of an experimental video, but the idea of a wearable LED vest for bikes, I believe, is something that might be interesting, which can hopefully improve road safety and provide better night visibility for cyclists. If you want to help improve on this product, you can find the code schematics, which are all free and available below. In fact, the whole thing is. Not exactly the best business model, but if it's used to improve safety on the road, then I guess it's a plus. Now, the whole point of this video was an attempt to make a project into somewhat a product and launch it as a bootstrapped startup. Did we manage to do it? Well, that's for you to decide. Oh, and also a big thank you to Francis for helping me out on building this product. If you'd like to check out more of his work, you can find this all in the link in the description below. Alright, roll credits. This is the part where everyone starts leaving the cinema, but if you're still here, you're the real MVP. This was definitely a long one and something experimental. Let me know if you enjoy this by dropping a like. Oh, and announcements. If you would like to support me to build bigger, better future projects, consider joining the Patreon. Your support would make this possible. And also, we now have a Discord community. Anyone who would like to talk or help out on future projects, you can find this all below. I'll see you there. Consider that the after party after this video, I guess. Alright, this video has gone long enough, so here are the key takeaways of my journey on screen. Alright, this has been a fun one, and thanks for watching. And until next time, peace. Roll credits.